differentiability, I posted the recorded videos. Can anyone observe that?
So you both in classroom.
In individual classrooms, I posted the videos. Just a concept. Share NCRT videos. I posted about continuity as well as differentiation. Once we can go through that, this is about continuity, this is about differentiation. First, you can see this continuity video, like what is continuity, how many formulas are there, what is discontinuity, how many types of discontinuity. Already we discussed it. Once again, you can go through that, right? Fine. B1, B2, and C section separately I posted, right? Okay, 19th question. Already we discussed. Once again, I'm going to explain you. So the given function is f of x is equal to x minus greatest integer function, right? So we have to prove that given function is discontinuous at all integral points. So we have to prove that at every integer it is discontinuous. Okay, right. I want to take a integer, like let us take x is equal to n is any integer, is any integer. Fine, students, right? So now I'm going to uh, find left hand continuity, right hand continuity at that particular given integer. Given integer is nothing but what are the integers? We having integers from minus infinity to plus infinity, like infinite integers are there. At what value you want to check that? See, I clearly explain you that for example, I want to, if I take n is equal to some 100 is a integer. First, I want to take just greatest integer of 100. What is the greatest integral value of 100? Is 100. That we know that. Next, I want to take next n minus. N minus means like 100 minus. 100 minus means the left side value of 100. If I take here the integer 100, so 100 minus will be left side. 100 plus means more than 100, lesser than 100. 100 minus means if I take, for example, 100 minus means 99.9999 like that. So what about this value is equal to? Is it equal to 100 or 99? Greatest integer. We are saying that integer. So clearly it is equal to 99 alone. Okay, 99. So shall I write this 99 as 100 minus 1? Yes, we can write. So n minus can be written as n minus can be written as n minus 1. Okay, in the same way, if I take a n plus nothing but 100 plus. To understanding, for the sake of our convenience, I'm taking n is equal to 100. 100 plus means okay, more than 100. I'm taking like 100.0001 or 100.999 till 9. You should not take a 101. So what about this point 100 point something value, some value? You can take otherwise 9999 like that also. Your wish. So clearly this is equal to 100. So what do you observe here? N plus is clearly equal to n, but n minus is clearly equal to n minus 1. So first of all, you should understand this. Okay. So I'm going to check that with continuity. Continuity is nothing but what? Limit extends to n minus. We need to find the f of x value. Limit extends to n plus right hand continuity at n and the function value. We need to find these three values. We need to find. Okay, fine. So first I am going to find one by one. One by one. I want to find the left hand continuity LHC. That is limit extends to n minus f of x. What is this limit extends to n minus f of x value is x minus step x. Now substitute this value in place of n. So x cannot be changed. X value simply it will becomes n minus n minus. What is the mean by this? N minus means n alone. You should not take like n minus means like n minus 1. So f of x, I mean x value becomes n alone, but the greatest integer alone. So what about to n minus here? Student, anyone? N minus 1, n minus value is? I already find this value, right? What is greatest integer of n minus 1? N minus n minus 1. N minus 1. So n and get cancelled. Shall I write LHC value is equal to less 1? Yeah. We got left hand continuity is 1. Then I am going to find right hand continuity. Okay. RHC. What is RHC? Limit extends to n plus f of x. Limit extends to n plus f of x nothing but again x minus x. Now you can substitute n in place of x. N minus n plus greatest integer alone will be changed n minus. So what is n plus? N plus, see here, n plus value is n alone. So substitute, it is n minus n, it is equal to 0. This is RHC. So left hand continuity is clearly 1, but right hand continuity it is 0. Right hand continuity 0, left hand limit is 1. Easier, both will be equal. Therefore LHC not equal to RHC. Hence given function f of x is equal to x minus fx is discontinuous at all integral points. All integral points. Having any doubts, students? To understanding purpose, I have taken 100. Actually, you no need to take 100 for any integer. You should write that n minus n plus 1. That's it. Like that, you can write. Is it clear? At every integer, left hand continuity should not equal right hand continuity, so that it is not continuous. Shall I proceed for next question? Question number 20. Question number 20, actually we can use the first formula alone because there are no two different cases like this. There are only one case, one function, that is. But to see here, the first given function. What is the given function? F of x value is x square minus sin x plus 5. Am I right? Okay, student. So x square minus sin x plus 5, I want to check whether it is continuous or not at x is equal to 5. Okay, if I want to use, if they give so the question for 2 marks, what are the steps you need to write? Clearly here, is it continuous? Anyone can say that is it continuous at x is equal to 5? Because see, when you see here x square is a polynomial continuous everywhere. Okay, sin x is a wave function. Okay, sin x is always continuous everywhere. Minus infinity to plus infinity, the sin x graph will be exist like this. Yes or no? So sin x is continuous. Constant function continuous everywhere. So already we discussed the property of uh, this continuity function. For example, f comma g are any two continuous function. I said very clearly f plus g, f minus g, f into g, f by g are also continuous. If we take any three functions like f comma g comma h or any function, f plus g plus h also a continuous, f minus g plus h also a continuous, like that. So here x square continuous everywhere, sine x is continuous everywhere, phi is continuous everywhere. So what we can conclude, we can say easily it is continuous at x is equal to pi also. It is continuous at x is equal to pi also in generally. But mathematically, how to write? So if they give 2 marks here, first use first formula. Use first formula means what is LHS? LHS means limit x tends to pi. X tends to phi f of x is equal to limit x tends to pi. F of x value is x square minus sine x plus phi. Right? Now here substitute in place of x 180. When I substitute here, pi square minus sine pi plus 5. So this is clearly equal to pi square plus 5. This what is sine pi actually? Sine pi value is 0. Am I right, student? Sine pi is 0.
Yes, sir.
Pi. So finally, left hand side is we are getting pi square plus 5. This is LHS. Then RHS is what? RHS directly f of phi. We have to find f of phi. So RHS value is f of phi is equal to in given function substitute pi. Pi square minus sine pi plus 5. Nothing but again this we are going to get pi square plus 5. Now left hand LHS equal to RHS or not? Obviously. It is RHS. This is the way you can find for 2 marks. But if they give for 3 marks, what are the steps you want to use? Simple. So this LHS, RHS will be same for even for 5 marks also or 3 marks also. They given for 3 marks or 5 marks. RHS will be same, but LHS alone you can find differently. LHS limit x tends to pi f of x. So this value I want to convert it into in terms of h. So what shall I write? X tends to pi plus h. I want to take. So, yeah, this value is x square minus sine x plus 5. Just a moment. Okay, students, right? So you can convert it into in terms of h. In class 11, we studied about first principle, how to convert. Simple, simple. In place of x, substitute pi plus h. Already I have written in place of x. See here, x replaced by pi plus h. Then h tends to 0. See here, when I substitute in place of h0, what will happen? In place of h0 means x tends to pi only will get. The value cannot be changed. So this can be written as limit h tends to 0. Here, pi plus h the whole square. First one, x square means in place of x, substitute pi plus h minus sine pi plus h. Okay, plus f5. Okay. So then fine. So here uh, pi a plus b whole square, limit h tends to j. Yes, simply we are writing some 2 3 steps extra. More for writing the more number of steps we can do like this. A plus b whole square, a square plus 2ab plus b square. What I want to do is sin a plus b formula. Sin a cos b plus cos a sin b. Okay, cos a sin b plus 5. Now you have to replace in place of h 0. What will happen? Pi square. Pi square. Here 0. 0 and everything is 0. Here 0. Sin pi already 0. Here it is 0, 0. Here cos h is okay minus 1. Cos pi is minus 1, but sin 0 is 0. So finally, what is the answer we are going to get? Pi square here, first value and last value alone. Plus 5. See here, this LHS. This is the second way, second method you can do like this. Right, students? So anyhow, here also same LHS equal to we got RHS. RHS already pi square plus 5. So therefore, LHS equal to RHS. Given function is continuous at x is equal to pi. Is it clear? I hope that it is very clear. So we proved that. Question number 21. Question number 21, since we know that here sin x is continuous, cos x is continuous individually. We know sin x continuous, we know cos x is continuous. But what about sin plus cos? Like you can take this is g, this is h. G plus g is continuous, h is continuous. G plus h continuous, g is continuous, h is continuous. G minus h also continuous. G is continuous, H is their product also continuous. So for that, what to do here? We cannot write directly. First of all, we have to prove that sin x is continuous separately, cos x is continuous separately. After that, you can write directly their sum is continuous, their difference is continuous, their product is continuous. Okay, let us see now how to write individually. Right, see here, question number 21. The first subdivision is what? Sin x plus cos x. Yeah. So f of x value they given like f of x is equal to sin x plus cos x. Now I want to check a given function is continuous or not. So let us consider I am taking g of x value is sin x. H of x value is cos x. Individually I want to check continuous or not. For that what to do? So whether is it continuous at enter the interval or not. So I want to take at a certain point uh, I want to check sin x is continuous because with the help of the graph we know very well the sin x is clearly continuous from minus infinity to plus infinity. There is no break and all. It is sine wave, right? But mathematically, let us do that at a certain point. Mm, I'm taking let x is equal to c is any point on the real line. Any point on the real line. Okay, I'm taking any point on the real line. Then after, okay, first step, LHC, left hand continuity. Or LHS. We can use the first. There are no two different cases, LHS, that is limit x tends to c. F of, not f of x, g of x. G of x. First, I want to check g of x is continuous or not. Limit x tends to. Shall I write? See, if you want to write more number of steps, what I said, this c you can write as c plus h. What is g of x value is sin x. It is like a previous question. Now I want to change it to in terms of h. So limit h tends to 0. What I said, replace x by c plus h. Sine of c plus h. Okay, then here limit h tends to 0, sine a plus b formula. Since we know that sine a plus b formula is sine a cos b plus cos a sine b. So after substituting sine a plus b, now in place of h substitute 0. Sine c into cos 0 plus cos c into sine 0. Since we know that sine c into cos 0 value is 1 plus cos c into sine 0 is 0. Finally, what is LHS left hand side value? This is clearly sine c. Then let us see RHS. RHS means f of g of c value. G of c. So RHS value is at x is equal to c. G of c value is sine c. What
Can
do
you
you
scroll up 1 minute, sir?
yes?
Sir, can you scroll up 1 minute, sir?
Yeah, sure. So
Okay.
in this, okay. Anyhow, this I'm planning to post in your classroom. This slide also.
Okay, sir.
Okay. See here. Here we got LHS equal to RHS. That is limit extends to C. G of x value. G of x value we got as G of C. Okay. Therefore, what we can conclude? Therefore, G of x is nothing but what? Sin x is continuous at x is equal to c. X is c is what? C is any real number on the real line. Any number on the real line. In the same way, you have to check that h of x at x is equal to c. So I am taking h of x is equal to cos x. See student, this sine and cos is very important. Okay, now I'm going to find same LHS. Now LHS value. Left hand side limit, that is limit extends to c h of x. Limit extends to, I said c plus h, same procedure. H of x value is cos x. Now I want to convert in terms of h. H tends to 0. Then whenever I write h tends to 0, replace x by what? X by c plus h. Now cos a plus b formula. Limit extends to c. Sorry, not extends to c. H tends to 0. Cos a plus b formula. Cos a, cos b minus sin a, sin b. So now after substitution, this again same, replace h by 0, cos c into cos 0 minus sin c into sin 0. What about this? Cos c into 1 minus sin c into 0. So finally LHS value is, left side value is, we got as cos c. Then we have to check RHS. RHS, what is the mean by RHS? At the given point, at x is equal to c, what is h of c? H of c value is cos c. Whether both will be equal or not. Clearly, LHS equal to RHS. LHS, RHS will be same. that we can write therefore limit extends to c. C is any point on the real line. Then h of x value we got h of c. Hence h of x is equal to, that is cos x is clearly continuous at x is equal to c. Nothing. What is the mean by this? It is continuous entire real line. That is means it is continuous everywhere. Sin a plus b formula, cos a plus b formula. Now after checking this, therefore what we can write clearly? You can write like clearly sin x comma cos x are continuous everywhere, continuous everywhere. Therefore f of x is equal to sin x plus cos x is also continuous. That's it. Okay, any question they give, given like which is related to sin and cos, first you should prove that sin x is continuous, cos x is continuous, like that. After that, their sum is continuous, you can write directly. This is first subdivision. What is the second subdivision? B. Same, f of x value they given as sin x minus cos x. Here also, after proving sin x cos x is continuous, clearly you can write here also same, clearly sin x and cos x are continuous functions. Then f of x is equal to sin x minus cos x is also continuous everywhere. Continuous everywhere you can write simply continuous, no problem. Then the third subdivision, what will you write here? Third, f of x is equal to sin x into cos x. Here also you can write the same procedure. Is it clear, student? Understood? Sin x and cos x you can prove it separately. If you understood very clearly about this 21, 22 becomes easy. So what is the 22nd question? Discuss the continuity of cosine. Cosine means just now I have written separately. I am taking h of x. That is the mean. H of x I am taking as cos x. In previous question, I proved that cos x is continuous. Cosine means cos x. Cosine means cos x is continuous or not. Yeah, it is continuous everywhere. Just now we proved. So next we have to do these three functions alone. Cosecant x, secant x, cot x. Just we have to check cosecant, secant, cot alone, because cos already we have proved in above. Right, I'm going to do this cosecant second. Second. Right. I'm taking, let us consider the function is f of x is equal to cosecant x. All student, I said very clearly, what about cosecant? Nothing but shall I write this value as 1 by sine? Yes or no? Cosecant x nothing but 1 by sine x. So when the function f of x is existed, a sine x must be not equal to 0. Everyone should remember sine x should be not equal to 0. If sine x is equal to 0, what will happen? 1 by 0. 1 by 0 nothing but it is clearly undefined. So in this question, what to do? How can you write that cosecant x is continuous or not? First of all, here also same. You have to take g of x as. In this question, let us take g of x is equal to sin x again. Again same sin x. You have to prove that g of x is continuous. That is sin x is continuous. After proving that, then clearly see Clearly g of x is continuous. Therefore, f is equal to 1 by g of x. F of x is equal to 1 by g of x is also continuous. Is also continuous. Continuous. If what is the answer? G of x should not equal to 0. When 1 by g of x is continuous, g of x must be non-zero. Okay, so f of x is equal to cosecant x. Cosecant x, what we can write? Cosecant x continuous, continuous at sin x not equal to 0. Therefore, f of x is equal to cosecant x continuous at. Can anyone tell that when for what value of x sin is non-zero? For what value of x sin is non-zero? X not equal shall I write n pi? N is belongs to Z. If n is equal to if I take x is equal to n pi means n is equal to 0, that value is 0. What is sin 0? 0. So we should not take up 0. We should not take pi. N is equal to 1 pi. Sin 180 0. Sin 360 0. Sin minus 180 minus 360. So that here sin x not equal to 0 means x must be not equal to n pi. In case x is equal to n pi, this value becomes 0. So x not equal. So therefore, finally, this is the answer. You should remember that f of x, that is cosecant x, is continuous at x not equal to n pi. You can take any value x not equal to n pi, it is continuous because sin x is not equal to 0. In the same way, you have to write for secant x. Okay, let us take same f of x is equal to secant x. Secant x can be written as 1 by cos x. So f of x is secant x is continuous. Continuous at when cos x value must be not equal to 0. Okay, can anyone tell when cos x is non-zero? Therefore, f of x is secant x is continuous at x not equal to 2n plus 1 pi by 2. Here n is belongs to again z. This and are enough. First you have to prove that here cos x is continuous. First you can take g of x as cos x. Cos x you can prove that continuous. Okay, then after you can write in the same way uh, cot cot x. You can take f of x is equal to like cot x. Cot x can be written as cos x by sin x. So when this cot x exists, sin x must be not equal to 0. Sin x, when sin x is not equal, like first subdivision. Okay, first one, like cosecant x. So f of x is equal to cot x continuous at x is equal to x not equal to n pi, n belongs to z. This sentence is enough. Here also what to do actually in this third, when they're asking cot x alone, first you have to prove that cos x is continuous, that numerator is continuous, then denominator sin x also continuous. You can write both. After that, you can write this step. Cot x can be written as cos by sin x must be non-zero like that. I'm telling you, student, this is the only slight quite difficult compared to all other exercises. Continuity in entire calculus, only 2 or 3 concepts are there. One is continuity, other one is some concepts are there in integration. So other 2, 3 only. So in that continuous is first one. So more concentrate on continuity. You have to practice once, twice, thrice until you understand. Okay, like that you can write 22nd. Coming to 23rd, Here they given two different cases. Two different cases. Again, we can do this question like previous question, like 14th question, 13th question, whatever you done. See, if you draw the real line here the point is particular point is 0. Okay, x is equal to 0. There are three cases will be there. This is x lesser than 0, right is x greater than 0. When x lesser than 0, x greater than 0, they given condition. X lesser than 0, the function value is sin x by x, lesser than 0. Greater than 0 and equal to 0, the function value is x plus 1. Greater than 0 also x plus 1. So finally, how many cases we have to write here? Three cases alone. If I take this value is k lesser than 0 or c, that's your wish, k or c. So what are the cases we are going to get? Case 1, some k lesser than 0. Case 2, case equal to 0. Case 3, case greater than 0. Okay, students? Oh, so right. This you can try this question number 23. It is very easy. K is lesser than 0. Clearly, sin x by x always continuous. We can use first formula here. First formula at exactly 0 because two functions are there. One is sin x by x, one is x plus 1. So you can use at x is equal to 0 second formula. Second formula. And at x greater than 0 first formula. You can try that. We'll discuss 24th question in next class.